Okay, guys, we can continue with our little tutoring sessions. This is related to the solving of this problem. The part one is in YouTube. You can check it out, and if you are ready for continue, we can continue with this part. Okay, like we were saying, this is the next part of our exercise. Remember, the pressure, it will be zero because obviously we will have atmospheric pressure here in P2 and here in P1, but atmospheric pressure, it's less atmospheric pressure, it will tend to zero because you don't have the water column for get pressure, or you don't have exit pressure on the output of the pipe. Because you don't have that two pressures, you can assume zero. Okay, that make easy everything. Okay, if you don't have pressure, the next part you need to solve is velocity. You already know the first part of velocity. It will be alpha because you already know it's related to energy of pumping and it's a turbulent flow. Remember, alpha is 1 when the fluid is turbulent and 0.5 when it's laminar. Okay, in that case, you can put 2 and you can put the velocity problem. The velocity, it will be in this exercise. Let me check it out. It's 2.111 meters by second. Multiplied by 1 plus the second part, it will be gravity. Gravity is 9.8 meters by second squared, multiplied by the difference between zetas, but in this case we don't have difference, we just have one height, and the height, it will be exactly 50 feet. That 50 feet, if you convert it in meters, you will get the final answer. And let me know if we already did it, because I think we already did it. Okay, in this case, it's this one. It's 15.240 meters plus the next part of the equation. And let me check some audio issues I think I will have. Okay, we can continue with our next part. In our next part, I hope that the audio problem is already solved. Okay, in this part, and the next part, it will be related to calculate or the influence of movement into the pipe. For that, we need a lot of things. For example, we will need the friction factor. From the Moody diagram, we already have it. The friction factor is 0.017. The velocity, it will be the same. It will be the square of the velocity. It will be the velocity number 2 for calculation. The longitude of the piping, in this case, is 50 feet or 15.240 meters. The by 2 of diameter, in this case, we are using the diameter of 2.067 inches, but we are moving that into meters for getting our final answer. Okay, with that information already know it, we can start solving this part of the problem. For example, for our frictional Moody diagram, it's friction is 0.017. 0.017. Remember, this doesn't have units for this one. The velocity is multiplied by 2.1. Oh, should point, and after the velocity, it will be longitude, the 50 feet, it converts to this little thing. And to the of diameter. In this case is 2 multiplied by the diameter, it's 0.0525. 0.0525 meters. Okay, with that information, we can continue with the next one. It's the friction coefficient. Remember, I don't know if we can project the presentation here. Let me try it. Okay, I will just put the formula from the other computer. Okay, we have, remember, it contraction and expansion. The first one is contraction when the processing start is between 1 and 3, and the second one is expansion when the process finish between 3, 2 and the end. Okay, we can start with anyone, but I will follow the formula just for the sake of the equations. Okay, in this case, the formula, it will tend to 0 when this one expand too much. Remember it. And in the case of this tends to 0 because the area number 2 is bigger, you need to use the coefficient related to that kind of area. In this case, remember the coefficient is, let me put the coefficient in a place outside the C if E, it will be one less area 1 and area 2 for the expansion. This is squared. But depending, remember, if this coefficient is too big because the area of exit is bigger than A1, the final answer, it will tend to be small and it will tend to 0. In that case, the coefficient related, it will be like 1 because this it make it 0 and 1 plus 1 is 1. In this case, the coefficient, it will be 1. Okay, just put it the 1 here. And if we got 1, we need the next part. It will be related to square velocity. It will be multiplied by 2.11. I think it was thus above, yeah. And the same, it will be for the coefficient of contraction. This is the first one, but the formula was in second. That's the reason, because I am putting in second. Okay, in this case, is similar. We will have an exercise when the tank the relationship between tanks is you need to first put A2 divided by A1. This is the input, the first part, and this is the output. In this exercise, it is same because A1 it will be bigger than the other ones, and in this case, this will tend to be 0, and in this case, the CFC it will be 10 to 0.5. You get that to the addition, it will be 0.5 between 2.11 qubits per second. And starting and the last one is a tricky one. This thing here, the factor related to the pumping, to the pipes, to the modification between the pipeline, that is the last one we need to solve. For doing that, we need our engineering tools. Let me know if I can put it in the whiteboard. Give me a second. Okay, guys, and continue with our session. And I already update the engineering tools for your review, and I put this little tool in the last part. It was a little difficult to get, but it has the coefficients for the main formulas we are using by the moment. For example, this one here. Okay. And maybe this one. Okay. It has unions, bulb, and the things we are using for our related operations. For examples, we have I will use this one for your evaluation, just the information you need for our working. In this case, I will just use the elbows. Okay. And letter coming here. We are getting the 0.5. Okay. And we are doing the equations again and again and again. In this case, we have 3 elbows. And the elbows are multiplied by the coefficient of elbows. Okay. And remember, flagged is different than treated. For example, when it's flagged is when you put with some kind of material like gums or gomas, and treated it's when it has rosca. In Spanish it would be rosca. Okay, for that the normal use of it's 90 treated, and in this case we are using maybe this one and this one. For normally the normal use of piping for food engineering is the last one, regular 90 treated. Okay, the long one it's not so common, but it's just a little bigger than the other ones. Okay, in this case we are using 1.5 for our coefficient, but we have 3 of them. Remember, you need to multiply it by the number of the the elbows you already have, and it's the same taking with the velocity with 2.11 111. Remember, you can use a little bit of algebra in this equation for making easier, because if you see this is a common factor between the the three of them, and you can mix everything in one and just doing the equation with one of them. If you want to save a little of timing when you are doing this kind of exercise, okay? By the moment, we have already all the information we need for our operations. I will try to take a photograph. Okay, and move to the app. Okay, I will just do some algebra to the coefficients for making easier my transformation, because it will take too much time to write everything. But if you take these ones It's related to the principle of factor common monomial. You just need to put it 1, 0.5, mm, 3, 4.5, everything in addition, multiplied by the common factor 2.11. By 2. 6. Okay. Just for making easier our calculations. And continue with our calculations. We are just using 1. In this case, we are cutting down the equation because we have 1, 2, 3, and 4 part of the equation instead of 7. Let me take a photo for putting in the other app. One, two, three. Oh, I think we are missing one. This one. Okay, and having it 6 multiplied by 2. Okay, we did it. Assuming everything is okay, this will be our final answer. Okay. This will be cubic meters by second. Okay. And with this information, we are just getting the last part. It's the power of pumping. We were related to this energy multiplied by the kilograms by second on the mass flow. I don't know the mass flow by the moment. And like you already know, you need to multiply the EP for the mass flow. But if you don't have the mass flow, you can, let me take this. This function is very useful, guys. I continue using it since now because I really like it. Okay. Cuando hablamos de nuestro sistema solar. Okay, for getting the mass flow, we can use the same caudal we already got. The caudal, or the volume flow, it will be related to this one. We already get our final answer about the caudal. It will be by second, sorry. And with this information, you can get easily the caudal. You are just multiplying by density, 1838.9 kilograms multiplied by cubic meters. In this case, you're getting, just for the sake of this part of the equation, let me put it there. Maybe if I do this, copy it and later put it on. Okay. Let me take a picture. Rodeado de 9 planetas. With 0.00457 multiplied by 1838.9. Okay. This in this case, let me take this amount, copy it, and put it here. Okay. Sorry, let me look for the symbol. Okay, it was vertical. And with this information, we got all final power. Let me multiply it. This is 687.7394 will be this joules per second. Or if you get the full unit, it might be kilograms, square meters, cubic seconds. Okay. If you want this one or this one, it will be the same. But this it will be the power you need for the pumping of the water. Okay. The nth line efficiency long as charge line contains. What we should the pump develop pressure the pump develop. This would be the final result of the pumping you will need. And just by this is what pressure it is, not pressure is just power. Sorry, it was a typo. I made sure it doesn't happen the next time. Okay, let me know if you have some questions to this exercise. I will update the quiz, and the only new thing is this calculation about the final power. We already did one in class, and the coefficient, it was a new thing too. That's the thing, because I did this before the midterm. Okay, let me know if you have any questions, and have a very nice day, guys.